Okay, guys, I'm recording. Let's settle down, please. Thank you. All right, so I want to go over the homework in great detail, just to make sure we're comfortable with this unit so far, that we don't feel lost, especially the second problem that deals with exponents, because I know we didn't cover properties of exponents in our last class and want to have that discussion. But first off, these problems here that say learning log, this is more just like a reflection-based question. I would like you to do it. I mean, it'd be good for you to just write a couple sentences of how you feel about the current topic. But this one, the second question is kind of a good one because it's a little more technical. Like, how does change in value b affect the graph? And this is dealing with the exponential function y equals b to the x. So something you could say about that is that when b is larger than 1, oh, computer's slow. I don't know why. Hold on. Let me close some things in here. Okay. That's probably better. Okay. So, well, it's not better. I don't know why. Okay. No clue why it's let me close some. Let me close Google. There we go. All right, maybe that's better. All right. So I was just a little sluggish. All right, now we're ready to go. My apologies. All right, so yeah, when b is greater than 1, that's growth. If b is between 0 and 1, that's decay. Those are things we talked about last class, right? So growth looks like this. So, obviously, if you have y equals like 2 to the x, right? You're multiplying by 2 every time x goes up by 1. So x is 1, y is 2, x is 2, y is 4, x is 3, y is 8, x is 4, y is 8, 16, and so forth. It just keeps doubling. Decay looks like this. It's dropping. Good example would be like y equals 1/2 to the x. So whenever b values between 0 and 1, we expect the graph to decline pretty quickly. So you can say things like that, whatever you want to say about what we did, it's just kind of up to you, but that's something that's a takeaway. So basically, what was the takeaway from the last lesson? Jimmy, go ahead.
I have a question.
Yeah, go ahead. Yeah.
Like, how do you say it's
Mhm.
dropping if there are arrows on like both sides?
Great question. Actually, it's a really good question. Which I probably didn't emphasize. It's my fault. As x approaches infinity, what is y doing? That's a question you're asking yourself. As x gets larger, what do we see y doing? So when x gets larger, that's basically moving left to right. Because, the left is lower x values, the right is higher x values. That's the way number lines work, right? And a coordinate plane is a number line. It's just one that's vertical, one that's horizontal. Sorry, horizontal and vertical. So as you move from left to right, are we going up or down? Is the graph rising or falling? Well, I think it's pretty obvious the first one, y equals 2 to the x. As we move from left to right, the graph is right. As we move from left to right, the graph is falling. That answers your question. That's what you do. That's all I ever do. But yes, it is an important thing to make clear because, yeah, you guys are still trying to make sense of like how to understand whether something's rising or falling, right? So anyway, let's just move on to the next problem. Okay, B11. Okay, for part A, I'm going to be a little bit long-winded about it because I think it's kind of important to understand what this really means. So 3x squared y d4 squared. So that square on the outside means you want to multiply the inside expression by itself. That's all it ever means. So that's what I'm going to do. And you'll see why I'm repeating these in just a moment. Now, I prefer you don't do it this way, but I think I just have to show you this just so we're all clear of how exponents work. So why did I write this out in such a long fashion? X squared means x times x, right? Now, if you don't see an exponent next to a variable, what do you see the exponent is? Yeah, one, so I just put one y, right? Then z4, of course, I put four z's. And because the square on the outside, I gotta do it again. So I do it again, 3x, y, z, 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 z. Now, 3 times 3 is what? That's pretty obvious. And then how many x's do I got? How many y's do I got? How many z's do I got? Done. So you could do it that way. I prefer you don't, because it could take too long. You'll go crazy. But that's all exponents ever are. Exponents are just telling us you got a base, and you have the superscript, that's the exponent, and the exponent tells us how many times I want to repeat the base. So if we have x squared, x being the base, I want that x twice. Or z4, I want that z 4 times. But then we have a 2 on the outside of the parentheses, I want the entire thing on the inside happening again, right? Now, there's a shortcut, though. The shortcut's this. You can multiply those two together. So first you have to do 3 squared, because the squared has to go, the square on the outside has to go to everything, right? It has to go to the 3, has to go to the x, has to go to the y, and has to go to the z. So you have 3 squared, and what's 2 times 2?
4.
4. And you assume that a y by itself has 1 as the exponent, but then when you do 1 times 2, that's 2. And then z, to what power? 8, because you're doing 4 times 2. So you can do that. That's actually the shortcut. And I totally encourage you to use shortcuts. What I caution you about is to not confuse the shortcut rules, which happens often. For example, and this is why I know you guys are memorizing math and not understanding math when you confuse these. Because you figure, oh, this is the addition or is the multiplication? I don't know which one it is, and you just guess. But think about it. X squared times x3. How many x is that going to be? X, 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 x. How many x's do I got?
5.
5. So you add in this case. In this case, you would add, because you have two bases that are identical, but you're multiplying those two powers, so you add the exponents. So in this case, you have x squared cubed, so I have xx, xx, xx. How many x is that altogether? 6. So in this case, you multiply. So definitely use the shortcut rules when you see something like this here, like 2 is going to multiply all the exponents on the inside. But just don't confuse it with this one right here. Just make sure you're being careful when you do this. So let's look at B. Okay, now PEMDAS is a big guiding principle, right? We definitely want to follow PEMDAS. So r squared s over r s cubed t raised to the third power. I would clean up the parentheses first. Everything inside the parentheses is clean it up. In fact, actually, I would break it up like this. Notice I'm compartmentalizing all the letters. I have a fraction for the r's, a fraction for the s's, a fraction for the t's. So we have r squared over r. How does that reduce?
R.
Just r, exactly. How about s over s3? How does that reduce?
2, but in the denominator.
Actually, it's s1 up top with s3 on the bottom. So if you have one s up top and 3 s's down below, how many s's will you be left with
That's 2.
after you cancel things out? 2 on the bottom, right? Yeah. So it'll be 1 over s squared. And of course, that's just t right there. Now, another thing to consider is that when you don't have a fraction, notice how r squared r became r. You can make it a fraction if you want. What do you put below it? Yeah, anything could be a fraction. If it's not, just put 1 below it. That's all. Why do I do that? Because when I have a bunch of fractions, it's nice to multiply all the numerators and multiply the denominators to make it one big fraction. So now when I multiply everything together, I get r up top and s squared t on the bottom. Does that make sense? That's good. 100%, yeah. Yeah, I do. But we're not done yet. Because we're cubing this, right? So if I cube it, then I distribute the cube inside, which would be R3, S6, T3. So that's a way you could do it. Clean up the inside, PEMDAS, parentheses, then do the exponent, which is the 3, take care of that, and then we're good.
Wait, why is R3 on top?
It's going to cube.
Because it's going to cube as the last step.
Oh, because I cubed everything first.
You could do that too, but then you have to clean up afterwards. So what Sam did, totally fine. I'm not going to hold that against you. Only thing is that just be mindful that you're following all the rules correctly. The reason I did it the way I did it just a few minutes ago, or 2 minutes ago, was because some people need a method. they need a process. And PEMDAS is a process a lot of people know so well. But like what you did is you said distribute first, right?
Yeah.
That's fine. That's totally fine. You just have to remember to clean it up correctly afterwards. R6 over R3 is R3. Yeah. S6, T3. It's the same amount of work. It's I don't think any way's better than the other.
But yeah, I know.
It's a preference, but the thing is that if you're following PEMDAS, I think you're less likely to make an error if you have a method to follow. That's my only advice.
Can I go?
Yeah.
Oh,
Sure, of course. Yeah, go for it. Yeah, you gotta stay hydrated, dude. Yeah, all right. All right. This is actually kind of a good thing to ask you guys. So part C, we're gonna use a process called FOIL. FOIL is an acronym. Do you guys know what the acronym stands for? Good, good. To be honest, I actually didn't know what those until I think college or after college. I just figured, oh, this is you just multiply stuff out. But it's an acronym: first, outside, inside, last. So you do 3m times 2m. Those are the first terms in each group, which is 6m squared. So that's the F part. And then you do the O part, the 3m negative 1, which is negative 3m, of course. And then you do the last ones, which is 7 and negative 1, which is, sorry, the insides, my bad, plus 14m. Then the last ones, which is negative 7. So that's the acronym: first, outside, inside, last. And then if there are any like terms, which the outside and insides typically will be like terms, combine them and you're good. All's all set, right? So that's what you're doing for part C. Now, another way you could have done this is you could have, what CPM kind of encourages, I think when you're in geometry, or if you came from a middle school and took Algebra 1, or took Algebra 1 here at our high school if you're a junior, is if you think about it, you could put 3m and 7 on the outsides, as well as 2m and negative 1. You guys remember how this works? You multiply the stuff on the outsides. So like in the upper left grid, 3m and 2m combined to be 6m squared. 3m negative 1 combined to be negative 3m. 2m and 7m become 14m. And finally 7 and 1 become negative 7. And then you just combine it, you get the same thing. So you can do it that way as well. Either way is fine for me. Now for D, there are not too many things that annoy me. This actually does. So some people report this as an answer. And don't worry, I'll forgive you if you make this mistake. But do you see the mistake I made? What's the mistake I made here? Yeah, you can't distribute exponents. Exponents are not distributive unless everything inside is multiplication or division. So for example, if I had 4 plus 5 squared, how would I do that correctly? Would I add the 4 and 5 first, or would I square the 4 and 5? Why? Because of PEMDAS, exactly right. You add them first and you get 81. But see, if you decide to bypass the order of operations, like, oh, I'm just going to do my own thing. I'm not going to care about the principles of math because I want to do it this way. All right, dude, you're not going to get the right answer. You get 41, right? You have to guarantee that whatever pathway you take, you get to the same end result. It's kind of like, I want to get to San Francisco from Appleton. I could take 280 or 101 or Caltrain, whatever. I'm going to end in the same place, but I got to make sure I'm taking the right path, right? Otherwise, if I go south of 101, I'm going to be in San Jose, not San Francisco, right? So you got to make sure you're following the right path to get to where you need to be. So that's, I know, kind of a dumb analogy, but hopefully that makes sense. So what I should have done here is do x minus 3 times x minus 3, right? Because that's what it means if you're squaring. X squared minus 3x plus 9, x squared minus 6x plus 9. So please don't distribute the exponent. The only time you could do that, if you had x times 3 squared, then go for it. Just like we did for part A, right? That case, yeah, sure. I distributed that exponent because I'm allowed to do that when everything's combined by multiplication division inside the parentheses. You have that as a property. Unfortunately, can't do that for D. All right, let's keep moving. For 12, that's just using proportions. Like, for example, let's say you see a tree outside is 20 feet tall. Its shadow is 40 feet long. Sam, you're 6 feet tall? 6'3". Okay, let's say 6 feet. I know you're a tall guy. Say 6 feet. So if the shadow's double the height, then what's if Sam is 6 feet tall, what's the shadow going to be? 12 feet, right? Because you follow the same ratio, right? So it's the same exact thing here. If I have 150 empty water bottles, that's 4.5 pounds. Great. So if I have 90 water bottles, it'll be X pounds. And you just cross multiply and solve. So you get 150X equals 405. And I just memorized this from the last class. I'm not doing this in my head. How tall are you, Alvaro? Okay. So 2.7. But who's wearing, well, what shoes? I say slightly.
Sorry.
But what kind of shoes are you guys wearing? Yeah, you're wearing tie tops, dude. Yeah. All right.
Like 6'1".
You're tall. You're tall. Yeah. All right.
You're short.
Anyway, just cross multiply and solve. All right, 13 guys. Let's quiet down. Jimmy, just let's focus things. Yeah. All right. So part A. B is number larger than 1. You have that. Okay. Between 0 and 1, you have this. And if it's equal to 1, it'll just be that. That's all. So it's just what we talked about in the first problem with the reflection question or learning log. Like, hey, what do you learn about what B does to the graph, blah, 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 whatever. So there you go. Okay, 15. This is a good one. I like this one a lot. I know homecoming's tomorrow. And people are talking about like they want to buy something. Maybe they want to buy a dress or a nice shirt or whatever. Let's say you're going to the store and some item you want to buy is $100. Okay. If that item has a 25% increase, how much is the item worth now? Exactly. Because you took 25% of the price and you added it on, right? So whenever you do an increase, you add on the percentage. So in this case, it should be 1 plus, or sorry, let me take it back. 100 plus 100 times 0.25. That's what's happening, right? But if you think about it, if you pull out the 100, you have this. So you're adding the percentage onto 1. So a better way to approach this problem is to say 1 plus R. Or 1 plus 0.25. Because remember, percentages can be expressed as decimals. You just move the decimal point from right to left twice. So 25% is 25. Oh, Kayla, can you hold on a sec? Let me give you this. Yeah. And I'll record the lesson so you'll have a chance to. Okay. All right. Okay, so that should be 1.25. So this would be 1.39. This would be 0.82. Oh, let me take it back. Sorry. Yes, my apologies. If you're doing a decrease, you subtract the percentage, don't add the percentage. My apologies. So this can be 82% of the last. It's going to be, you drop it by 18%, so it's 82% of the previous price. If you're looking at prices. So 0.82. And lastly, if you're doing a drop of 94%, it's 0.06. Sorry, it's yeah, the multiply is 0.06. Okay. So that's how you deal with changes percentage, is that you do 1 plus R, 1 minus R, depending if it's increase or decrease, and then replace R with the decimal equivalent of the percentage. All right, 17. And I'll stop there and we'll do the lesson. Okay, let X, when you deal with word problems, define your variables first. You guys quiet, please. Number of years since 1905. Because if I read the problem, in 1909, Charlie had an heirloom of marbles, had that many. His great-grandfather started the collection in 1905. Each year, he added the same number of marbles to his collection. So it's a linear function. He passed it on to his son, and then every future generation got it passed on to them. And he's had to maintain this yearly add-on. In 1966, they happened to tell you that there's 810 marbles when his father received the collection. So that's why I'll let X equal number of years since 1905, because it started in 1905. And Y, of course, will be the number of marbles, right? In any particular year. So let's make a table. Table is a good way to kind of analyze this. So I'm going to let X be 0 for 1905, but I don't know how many marbles were in 1905. I don't know. So I'll put a question mark. I have no idea. Now, in 1966, how many years have passed from 1905 to 1966? 61. And there's 810 marbles. How about in 1999? How many years have passed now since 1905? Good. And there's 1239 marbles. And this is the big hint. Added the same number each year. So it means you're dealing with a linear function. And what's the main formula we typically use for linear functions? Y equals what?
MX with V.
Totally, right? M represents slope. So how do I find my slope? What would I do?
Plug it in.
Yeah, you guys know this. 1239 minus 810 over 94 minus 61. Does that make sense? I think that's 429 over 33, which I think is 13 because I just did that in the last class. So I think it's 13. That looks like a B. Let me fix that. 1, 3. Okay, we're good with that? 13? Yeah. All right, great. Okay, so y equals 13x plus b. I don't know the y-intercept though, right? So y equals 13x plus b. I could solve it. If I plug in, say, 61 for x and 810 for y, I can solve for b, right? And again, I did this in the last class. I know the answer is 17. So use a calculator, mind you. Again, I just did this in the last class. So now I can answer some of these questions. By the time Charlie inherited the collection, how many years have been in existence? 94 years, obviously. How many marbles are added in the collection each year? 13. I found the slope. How many in the original collection? 17. Generalize the situation by writing a function. Now I could do that. And lastly, for E, in what year are the 2000 marbles? So you solve it. Again, I did this in the last class. I trust you guys can work this out, but it'll be about 152 point something. I think it's 152.3.
I got 153. Yeah, me too.
Okay, let me double check.
Oh, no, just because like I got the decimal.
You rounded up.
I didn't think you could have like a decimal in here.
Actually, you think you're right. Hold on. Yeah, it's actually 152.53. It's also 153 years. That's fine. Add on to 1905, right? That's going to be the year 2058.
Mhm.
Yeah, so 34 years from now. So yeah, that's so again, it helps to make a table. So you can organize information very nicely. Assign your variables too, know what the variables represent, then make a linear function, which you guys know how to do, and then you can answer the rest of the questions pretty smoothly. So okay. I know I spent long time on it, but I want to make sure we're comfortable with the homework. Now, you still need to turn in, it's okay. Turn over the weekend, I'll still give you full credit. Don't worry if it wasn't in by 8 o'clock this morning. I know you guys had a lot going on with tests and other stuff. And then the factoring packet, I'll give you guys some time in class if you want to work on it. I pushed this deadline out till Sunday night, so try to get it done by Sunday night. And I think what I'm going to do every unit is give you some sort of drill packet that kind of ties close to what we're doing. So the next one we're going to do is simplifying exponents. So I'll make sure there's an exponent packet you guys get on Monday, or in your case Tuesday, just so you guys are getting another practice with the key concepts in the unit. So sometimes drill and kill is good. CPM doesn't do it, so we'll supplement that. Anyhow, let's move on to today's lesson. So let me give you the notes for today. Okay, these notes are for the whole unit. So for the rest of September. So they do have extra copies. I'll push these. I'll publish these to Schoology when I get the chance. More. Oh yeah, there's more. I got a little worried. Then maybe a little extras. Good, John. And then, of course, I need to pick you guys up too. Sorry. Okay. Alrighty. Okay, so this lesson should be pretty short. It's only 2 pages. But still want to get a little detailed. So standard form for an exponential function looks like this. Where A is the initial value and B is what we'll call the growth slash decay factor. Because sometimes the graph will decline, not increase, right? Sometimes that could happen. Now, looking at this example here, what does A represent? Well, we just answered that question. What does B represent? We answered that question. So those 2 questions have been answered in part A. Now, how do you identify A by looking at a table? Actually, what is A first? What is A in this problem? It's 3, right? And what's my B value? 2. Right, just look at it, right? Just extract it from the equation. It's pretty clear that number on the outside is 3, and the number on the inside parentheses is 2. And so using the raise to the x power, and multiply by 3 afterwards. Or PEMDAS, do exponent before multiplication. So you're going to raise 2 to some power and then multiply by 3 afterwards. So let's make a table, because part B is saying, how do you identify A by looking at a table? So let's do a table. Let me plug in these 3 numbers. Let's start by plugging 0 in. Just by looking at the table, or if you plug 0 into the equation, sorry, looking at the graph, or plug into the equation. When x is 0, what's y going to be? It's 3. When x is 1, what's y going to be? What do you think? When x is 1, it's going to be 6, right? Now, if it's -1, if I look at the graph, I know we haven't done with negative exponents yet. We haven't dealt with that. But when x is -1, yeah, 1.5 or 3/2. Yeah, go. It's fine. Yeah, it'll be 3/2. Well, here's the deal. When I have, let me erase this stuff here. Can I erase that?
Yeah.
Okay. No. All right, so yeah, when you raise something to a power, for example, we know it means this, right? You don't have to write this down, by the way. I'm just kind of explaining why 2 to 0 is what it is. Now, if you think about it, any number times 1 is always itself, right? So when you have 2 to the 4 power, we know what that means. It means multiply 2 4 times. 2 cubed, what does that mean? Multiply 2 3 times. 2 squared, I want 2 twice. 2 I want 1 2. 2 to 0 means I don't want any 2's, right? But what do you put as that answer when you put 1? The reason why you put 1 is because there's an invisible 1 being multiplied to it. We don't realize it, but it's there. Any number times 1 is itself. So you could always put a 1 times whatever, and it's going to be the same thing. Doesn't matter. We just don't write it because it's redundant. It's kind of a waste of time. We can. So, but as a power, we know what power sample, right? 2 to the 4 means, hey, I want 2 4 times, I want 2 3 times, I want 2 twice, I want 2 once. I don't want any 2's. But you don't put 0, you put 1 because there's a 1 being multiplied to it. So right, there's no more 2's, but there's still a 1 there. Just like with all the other cases, we just don't show it. So that's why we have something raised to the 0 power. It's going to be 1. So when I plug in 0 into the equation, hold on, let me erase that. Wait. Sorry, I'm just like delete. Sorry, that's what I meant to do. There we go. Yeah, when I plug in 0 into the equation, that's 3 times 1, which of course is 3. What if I plug in 1 for x? I get 3 times 2, which of course is 6, right? Now, this one I haven't taught you guys yet. If you know it, great. If you don't, it's okay. Negative exponents cause the base to flip. So 2 is 2/1, right? What happens when you flip 2/1? What does it become? Exactly. And that's why it's 3/2. So I haven't taught you guys negative exponents yet, but negative exponents flip the base. So whatever the base is, write as a fraction and take the reciprocal or flip it. So when you have x in -1 power, that's 1 over x in general terms. So that's what negative exponent does. We're going to cover negative exponents next week. So I'm kind of just doing some things a little bit in advance, but it explains you why you have that point, -1 comma 3/2. Because when you flip it, the 2 becomes 1/2 times 3, that's 3/2. Sure, of course, yeah, go for it, yeah. Now, how can you locate A in the table? So to answer the question here, let me erase everything else. How can you locate A in the table? It's essentially the y coordinate when x equals 0. That's all it is. Just the y coordinate x equals 0.
Isn't that just the y-intercept?
It is actually. Yeah, you're right. Actually, I don't know. I didn't think of the last class. No one said that. Good job, Jimmy. Y-intercept. Yeah, it's y-intercept also. Yeah. That's how you find a graph, I know. But now how can you find the situation? Just your starting value. Say, for example, you're looking at like population growth and you're doing an exponential model. It would be the starting population, right? So, that's how you'd may see in a situation. So it'd be the starting value. All right, B. How do you determine B? B is going to be the common ratio. We're almost done. There won't be too much longer. I know you still got another class. I know. I still got to teach another class.
You have G period?
Yeah.
Oh, that's so slow.
Yeah, it totally is. Tell me about it. I was not having my schedule. I love the class.
Do you have like A? Do you have an A?
You don't have, wait, but you don't have class, I know, Thursdays, you don't have, class before lunch.
Have an A. We have had special schedules the last couple weeks.
E?
Not yeah, yes, too. I'm Let's go to schedule. Actually, I just closed my.
Do you teach every single period?
No, of course not.
There's no teachers teach like.
Four full time. Some, if they teach 5, they get paid extra for it.
I'm gonna be looking 6.
Oh, you're right. No, because it switches. Yeah, B's before lunch. I don't have B period or C, but I don't. I have an A. Yeah.
You have a C?
But see, this is what I'm saying. Like all these special schedules, right? Like, look, that was that schedule. This is this schedule. Then it changes again. Then it changes back. It's a frustrating schedule. Like it's just like it's not consistent. There's a prayer on Wednesday, and it's with all the network schools. So we're doing another kind of mass prayer thing. I don't think it's a dress attire day, but
Are you serious?
There's like a Zoom, like, isn't it?
yeah, to Zoom with the other network schools. Yeah, they'll take attendance. It's where office hours starts first that day.
So how long is it gonna go after that?
No, but then I think you gotta get. Wait, next Wednesday?
Next
Yeah.
Wednesday. Yeah, there's office hours, then prayer, then C period. I wonder why I think they had to do it to time with all the East Coast schools. I don't know why.
11:30?
But I think what they want is they want to honor the early start, the late start. They don't want you to come in at 8 o'clock in the morning because we're supposed to do late starts on Wednesdays anyway.
Wait, is the prayer on Zoom?
Yeah, I'm coming at 10.
But
Yeah, but then that week.
but I think no, we're gonna be in Harmon.
Oh, it's like Zoom, like not at home.
No,
Oh.
Mr. E.
it's Zooming with the other schools in their schools. Sure.
Yeah, then we have like a bunch of classes on Friday. Because we have prayer service on the.
There's no advisory.
Oh, that's right.
So.
This is your.
Do I have to show up early to school for office hours?
No, if you want to, you can. No. Hey guys, let's get back. Let's finish this up, guys. Let's finish it up. Anyway, for part C, how can you determine what B is? It's a common ratio for Y for consecutive points. So look over here, right? What's the ratio between 6 and 3? 2 to 1. Exactly. It's 2 to 1. So that's how you can find what B is. Just look at the ratio because you're multiplying by over and over again. Or what's the ratio between these two? It's still 2 to 1. If you divide 3 by 3 halves or 3 by 1.5, you still will get 2. So that would be the B value. Okay. I see what you're saying. That's for going backwards. So you're going backwards. I'm talking about going forward when X is increasing. Because as X gets bigger, what is Y doing? No, I see what you're saying. And you are correct. But for the sake of writing the equation, because we're assuming growth, we want to, as X increases, Y has to increase. Okay, let's try another one here, guys. So a bouncy ball. Let's say you drop a ball. It bounces. As you imagine, the ball will bounce back to a lower height and eventually it'll stop bouncing, right? So what we need to notice is the ratio. So my ratio, guys, quiet, please. Ratio is this. You guys stop talking about your hair. Let's get back to this. All right. We heard you. It's all good. I'm just gonna tease a little bit. All right. Okay. So 67.6 over 84.5. Again, I did this with the last class. I already know what it is. The answer is 0.8.
Okay.
Hmm? 0.8. It is, but it's actually spot on. This is it's actually exactly 0.8. Okay. What if I do it again?
0.16.
No. If I no, you are, well, actually it'd be 0.64 if you multiply 0.8 by 0.8. But no, what I'm asking is what if you compare the next 2 points? You still get 0.8. It's still the same thing.
I think that's the B.
That's a B value, guys.
I'm joking.
Okay. So how did I find it? The values too. Now, if I go backwards, I gotta multiply by 0.8. So if I want to find the height when the bounce number is 1, what's the opposite of multiplication? So you gotta divide it. Now, this one I'm not gonna attempt to do in my head. And I can't remember from the last class. Bad right here. It's 105.6. If I divide again, Jimmy, stop talking. You get 132. Okay. You get 132. So, yeah. So the rebound ratio right here, the height, an equation, y equals 132 times 0.8 raised to the x power.
Sorry, how do you get the 132?
I just kept dividing by 0.8.
I'll see you divide 84 by, you divide 105 by 0.8.
Exactly right. So it's a little messy. Okay. All right. We good?
Yeah.
Cool. Let's keep moving. Okay, part B. These are more situations that involve exponential functions. The question is asking you, how many people founded the company and how can the growth of the company be described? They give you an equation to describe the growth of the company. That equation describes growth of the company. Y equals 3 times 4 to the x power. What's my A and what's my B value here? Now we know about A and B for how to identify them. What's A here? What's B? So how many people did we start with? What's the initial value?
3.
And how's it growing? You multiply by 4 each year. Let me you multiply Y by 4. Each year. Okay, we good with that?
Yeah.
Cool, good. Great, awesome. Now let's look at part C. You have some computers are being infected by a virus. Right now you start 27 computers. So how many computers are in the technology center? 27, right? Because we started 27 computers. This is a tricky question. What portion of virus-free computers is infected each day? But look at over here, though. What does the Y column represent? Does it represent infected or uninfected computers? So you have 27 are not touched. After one day, 18 are cool. So how many got infected? 9 are not cool, right? 9 are pretty bad. So if you want to know what portion is infected each day, you can do 18 over 27 and find that ratio, right? Which, by the way, is 2/3. But that's going to be the ratio for uninfected computers. I want the ratio of infected. So how many are infected after the first day?
Okay.
So I want to do 9 over 27. So you got to read carefully. That's what you got. You really got to read carefully. So 1/3 is infected each day. And the next question is how many will be infected by the end of the third day? So now I know. Or sorry, how many remain virus-free at the end of the third day? Sorry, that's what I meant to say. Virus-free. So the equation is going to be Y equals 27, but I'm going to do 2/3 to the x power because the ratio is 2/3 for the table. And if I plug in 3 into that, I should get 8.
Why did you do 2/3, not 1/3?
Because the question is it's asking something different. The second question is asking what portion is infected.
Okay.
The third question is asking how many are virus-free. So I had to be somewhat flexible with changing the base depending on what the question is asking.
Okay.
So that's what you just have to read carefully. Okay, read very, very carefully. If you plug in 3, you should get 8. Plus the fact that you're dropping by 1/3. So if you take 12, 1/3 of 12, but drop it, 12 minus 4 is 8. Okay, last one. And then you guys can chill for a little while. And we get out what time? 2:05? Okay, good. Perfect time. This is exactly where I left the other class. As a part of major scandal, it was discovered that several statements from the prospectus for Expo Grow in Part B were false. Now the company has 5 founders and they double in size. So if they have 5 founders, what's A going to be? 5. And if you're doubling, what's B going to be?
8.
No, if you're doubling in size, what's your base value? Your B value? 2. Right? If you're doubling, you multiply by 2.
Oh,
Right?
I thought you're doubling B.
yeah.
No. Well, what would be the B value if you're just doubling in general? Well, your base would be 2, right? Because you multiply by 2 over and over again, right? So it's 5 times 2 to the x power. So the company had 3 founders and they were quadrupling the number of employees every year, but really they should have been doubling. And they didn't recognize that it's actually more than 3 founders, actually 5 founders. So anyway, the homework I have already printed out. I'm gonna hand it to you guys. So you guys can do that. Or if you want to work in the factory pack, or if you just need to chill, you need like 12 minutes just to decompress to get one more class left. I could use that too. Anyway, we're all done.